Okay, so today I want to do a little bit of looking back at factorization. I'll write some problems up here and you can pause and have a think about what you remember how to do. The instructions are to factorize if possible. And it is important to know that not everything can be factorized. The importance of that is that when you're looking at things, you have to be able to tell whether there's more to do, whether factorization is an option. So it's not enough to just be able to factorize. You also have to be able to kind of conclusively say, yeah, this can or can't be factored. Okay, so go ahead and press pause and take a stab at these and then circle back and let's do it together. All right, so for this first one, this is just classic common factor. You have an x in both of these terms. So we can rewrite this as x parentheses b minus a. So factorization is the opposite of multiplication in the sense that I'm undoing the operation. So if I multiply x times parentheses b minus a, then I get back to xb minus xa. Okay, so that's kind of an easy one to start. Easy to see. What about this next one? X squared minus 4. So this is a little bit harder. There's no common factor, but you have a situation where you have what's called the difference of squares. So x squared is x times x. 4 squared is 2 times 2. And if we multiply x minus 2 times x plus 2, it turns out that that middle term will knock itself out, right? So if we look at this, what you get is x times x, that's x squared. You get minus 2x and plus 2x. And then you get the minus 2 times plus 2. So this term goes away and you end up with x squared minus 4. So this can be factored into x minus 2x plus 2. Okay. So in a similar fashion, the next one is also the difference of squares. One is a square number. So we have ab minus 1, ab plus 1. And again, if we multiply it all out, we can see that we end up with ab squared, ab times ab, ab, minus ab plus ab minus 1, a squared, b squared minus 1. Now, just a quick side note. If you were confronted with something like y squared plus 9, this is not factorable, not without complex numbers, because there's no way to get the y squared and the 9 term and the cancellation that you need. So great example of an expression that is what it is. Okay, I'm going to rewrite the next one in descending order in terms of the powers, x squared plus 2x plus 4. So as you're considering this, you know, the binomial factorization, you know, you start with this trinomial and you're trying to end up with 2 binomials in parentheses. There's a lot of different instructional approaches to like being able to do this, but for me, the most basic understanding is, you know, how am I going to get the first term? Well, x squared is going to come from x times x. How am I going to get 4? That's where I start to have options. I could have 1 times 4. I could have 2 times 2. If I wanted to get into negative numbers, I could think about it that way. And now I'm starting to think about how am I going to put these numbers in place here and here so that when I get those middle terms, I'm going to end up with plus 2x. And the answer is that I can't. There's no combination of these that's going to make me have 2x in the middle. I'll just do one as an example, and then you can go through the rest on your own. So if I tried this, I would get the x squared, I would get the plus 4, but what I would get in the middle is I'd get 5x. Where's 5x coming from? Well, you got the 1 times x, and you got the 4 times x. So you got 1x and 4x, and that makes 5x. So this is not what I want. I don't want x squared plus 5x plus 4. I want x squared plus 2x plus 4. And an examination of all the rest of these. And as you kind of get better at this, you can really just look at the numbers and see, you know, that you're not going to be able to get a combination of 2x. So this is not factorable. All right, let's hit this last one. 3x squared minus 5x minus 2. Okay. So this time I have some more choices in the front. I could have 3x and x. I could also have x and 3x, but I'm going to kind of leave it here and then examine the back end. Let's see where that takes me. So this is 1 times -2, but also could be maybe 1 times 2. And because this is asymmetrical, it matters what the order is. So then it could also be -2 times 1. It could also be 2 times -1. So really there's 4 options here that I have to work through to figure out how am I going to get this middle term of minus 5x. And so again, one of the things that I really emphasize when I teach factorization is binomial multiplication as a means of understanding what your options are. So for instance, when I do 3x plus 2 times 4x minus 1, if you just look at that inside-outside part, minus 3x plus 8x, you can see that the middle term is going to be 5x plus 5x. That's a useful skill when you're kind of mentally putting these numbers in, because I can see that this first option actually is exactly what I want. If I put the +1 here and the -2 here, I end up with minus 6x plus 1x, and that gives me minus 5x. And there's my magical middle term that I wanted. So this is the correct factorization for this last one. 3x plus 1, x minus 2. It's been a while since you thought about factorization. I'm sure that seems a little bit foggy, but it's the kind of thing that you can practice. Probably the easiest thing to do is actually go into our textbook and go back and find that factorization section. Here, let's do it together. So I'm going to stop share here, reshare. First. All right, and I go to view online. All right, here we go. There you go. Factoring polynomials 1.5. And you can just skip all the way to the problem section and knock yourself out. Yep, plenty to practice on there. So no excuses. You know, you've done factorization before. You got through college algebra, I hope, and you know it's a really important part of being able to solve some of these upcoming trig equations and identities. So really critical. All right, on to some fun identity stuff.